We're in section 5.7. This section has one rule, and that rule is the negative exponent rule. If you have a base to a negative exponent, that tells you to move it across the division bar. So if it's in the top, like b to the negative m, we're going to move that to the bottom, and it becomes b to the positive m in the bottom. If you had an a to the negative n in the denominator, you're going to move that to the top, and that becomes a to the positive n. A negative exponent means to move. Your directions for this entire section are to perform the indicated operations and always write your final answer using positive exponents only. Your book has special rules for subtracting these exponents, but I really think that my way is a little bit easier, so I'm going to continue to use my way instead of using the book's way. Your first problem is x to the fifth divided by x to the third. So you subtract your exponents, 5 minus 3, and that gives us x to the second. Since the 5 is larger, that means that the x to the second result will go in the top. My next problem is x to the fifth divided by x to the ninth. Starting with a larger number, you say 9 minus 5 gives me 4. So that's going to give me x to the fourth. Since 9 was larger, that tells me that x to the fourth goes in the bottom, and my answer would be 1 over x to the fourth. Those problems you saw in section 5.5 as well. You will definitely see them again. In your next slide, you have negative exponents. Each one of these has a negative exponent, and a negative exponent means to move. The first problem is 6 to the negative 2. That's understood to be in the top. So we want to move it, and when we move it, it goes to the bottom. 6 squared is 36, so your answer for this one would be 1 over 36. My next problem is 4 to the negative 3 divided by 5 to the negative 2. 4 to the negative 3 has a negative exponent, so we have to move it across the division bar, so that becomes 4 cubed. 5 to the negative 2 has a negative exponent, so we have to move it in the opposite direction, which would make it 5 squared in the top. Simplifying those out, 5 squared is 25 in the top, and 4 cubed is 4 times 4 times 4, which is 16 times 4, which is 64 in the bottom. Your next problem is 1 over 2 to the negative 3. This negative 3 exponent tells me to move it, so I'm going to move it up, and that becomes 2 to the third. 2 to the third is 2 times 2 times 2, which would give me an answer of 8. The last one on this slide is 1 divided by 4x to the negative 3. What you have to remember here is although 4x to the negative 3 is one term, it has two factors, and this 4 is actually understood to be 4 to the 1. The 4 to the 1 has a positive exponent, so the only term, the only part, the only factor with a negative exponent is this x to the negative 3. So the x to the negative 3 moves to the top, but everything else stays exactly where it is. So the 1 stays where it is, the 4 just goes straight across and stays where it is. So your final answer for this one would be x cubed over 4. Let's try another one of those. So you have a negative 7, x to the negative 4th. This negative 7 is understood to be a negative 7 to the 1. I also want to point out that negative 7 here is a coefficient. Coefficients can be negative. The items that can't be negative are exponents. So in other words, this x to the negative 4, it's got to go. It has to move. So the x to the negative 4 moves to the bottom. The negative 7 stays exactly where it is, and your answer is negative 7 over x to the 4th. Again, the negative 7 is okay because it is not an exponent. In your next example, you see an x to the negative 9, x to the 4th. X to the negative 9 is bad, so it has to move. but the x to the fourth is good, so it's going to stay put in the top, and the x to the negative 9 is going to move to the bottom because it had a negative exponent. What you have left is your basic subtraction rule. 9 minus 4 would give me x to the fifth. Since 9 is larger, you would get x to the fifth in the bottom. Your next problem is 25x to the 8th divided by 5x to the 10th. Take them piece by piece. 5 goes into 25 5 times. 10 minus 8 would give me 2 x's left. Since 10 is larger, the 2 x's would be in the bottom. So this would be 5 over x squared. The last one on this slide is the power rule. When you raise a power to a power, you multiply. So even though they have negative exponents, you're still going to multiply them. So this is A. Negative 7 times negative 5 is a positive 35. Then you have B. 2 times negative 5 is a negative 10. Now that we see that product, I recognize that this negative exponent for the b, that means that one has to move. So you would actually get a b to the 10 in the bottom. The a to the 35 stays where it is because it is positive. So your answer would be a to the 35 over b to the 10th.